Look at Unit 6, Activity 6, and it's really quite tricky, I know. I'm going to give you a quick explanation that this is 60 degrees, okay, and this has got to be 1 because I'm going to use a unit circle, so all the way around the outside is just 1 to make my life easier, okay? So what would be the sine of 60 degrees? Well, sine is equal to opposite over hypotenuse, right? So sine 60 equals the opposite over the hypotenuse. The hypotenuse I'm forcing to be 1 right now to make my life easy. So the sine of 60 is equal to just the opposite, and sine of 60 is 0.8660. So the sine of whatever angle is in here is going to give me this vertical component, how high this side is, alright? And you can see up to here is 1, so it's a little less than 1, so it's 0.8660. It happens to be a horrible number. What about if I did cos of 60? Cos 60 is the adjacent over the hypotenuse. Cos of 60 equals the adjacent over, I know the hypotenuse is 1, so the adjacent is just strictly the cos of 60, and when you type in your calculator you get 0.5. So the interesting thing is sine of the angle gives me the vertical component, and cos of the angle gives me the horizontal component. That's the only important thing. Okay? What if I took my line and I put it somewhere else? So I'm going to take a new red line, and I'm going to stick it over here, going this way. I want it to look really similar. Okay? Well, clearly the vertical component is 0.8660 again, and the horizontal component is going this time to the left, so it's negative 0.5. And if I did, oh, what angle is this? In here is 60 degrees. It's a similar triangle. That's why I know that if this is 1, this side has to be length of 0.5, and this side has to be length of 0.86. It's the same triangle, just flipped over. But what angle is it? If I went from here, 0 degrees, there's 90 degrees, there's 180 degrees, starting from here going counterclockwise, this is 270 degrees, and in fact, if you want to go back here, here's 360 degrees. Alright, so going from here all the way to there must be, well, it's not quite 180, it's how much less? It's 60 less, so this must be 120 degrees. And if I did sine of 120, I should get 0.8660, 0.8660. Alright, so isn't that interesting? Sine of 60 gives me 0.8660, and so does sine of 120 gives me the same answer. Your calculator is always going to want to give you the answer, the small answer, between 0 and 90 degrees. So if I went the other way, for example, and I said, what's the inverse sine of 0.8660? Shift sine of 0.8660, it's going to give me shift sine 0.8660, it's going to give me 60 degrees. And if I did shift sine of 0.8660, I should give me 120 degrees, but my calculator only gives me the 1. So this point is to say there's another angle that works for it. Sine of 60 and sine of 120 both give you this. Your calculator only spits out this one. Similarly, cos of 120 is equal to negative 0.5. Alright? So cos of 60 gave me 0.5, cos of 120 gives me negative 0.5. So the triangles kind of get related, and the hard part is to figure out how they're going to get related, so you have to draw a diagram. So let's try this example. What if I said sine theta equals 1 over 4? Well, the opposite is going to be 1, and the hypotenuse is going to be 4, so it's going to look something like this. The opposite is 1, the hypotenuse is 4, the adjacent, I don't know how much that is, but I can work out that angle. So theta must be shift sine of 1 over 4, and that gives me 14.5 degrees, 14.5 degrees. But what if I said there should be another angle that works the same? How far around do I have to go this way to look the exact same triangle so that that's also 14.5 degrees? So if I went all the way around to there, that angle should be 180 minus 14.5 is 165.5. Alright, so let's double check. Sine of 14.5 gives me 1/4, and sine of 165.5 also gives me 1/4. So I can check afterwards, but if they ask me what are the two angles, theta can equal 14.5 degrees, but it can also equal 165.